One of the examples that we come across in Module 6 post-test is this one. So let's take a look at it and see if we can unravel the mystery. The population of a particular city is increasing at a rate proportional to its size. Okay. It follows this function, which will be P of t is such that 1 plus k e, natural log there, of 0.12 t, where k is the constant and t is the time in years. If the current population is 24,000, in how many years is the population expected to be 60,000? And this is critical, round to the nearest year. All right, so we will convert this later to a natural log problem, but our first thing to do here is to solve for k. So this ties in with chapter, I think it's module 3 maybe, the end of module 3, where we had these proportions and direct variations. So this is a sort of direct variation. So let me set this up for you. So to do it step by step. So here we could say the year is 0, that is the beginning of it, and it's 24,000. And then later, we don't know this year, but we'll call it t. It's going to be 60,000. So let's put that into this function, and we want to solve for k first. So we'll use our y value of 24,000 to replace the function symbol. Remember, we can always replace this with the letter y. The 1 stays here. Now the e that we're going to raise to this power, we have a value for t there. Our value for t is going to be 0. So this times 0 is 0, and e to the 0 power is 1. So we could write a 1 here for the e, or just leave it this way, because now we're going to solve for k. Well, that's pretty easy. This just becomes 2, 3, 9, 9, 9. Well, we now have a value for k. What do we do next? Well, we're going to replace in our original formula our value of k. The e comes down and it's to this exponent. We don't know the t now. The t will be the number of years. So we're going to subtract 1 from both sides and get 59,999. And now we're going to divide both sides by this so we can isolate the e to this power. We're now going to convert this to natural log of both sides. And we know that the natural log of something, the base is e, and when we get this combination, it actually just becomes this, 0.12t So what we're now going to do is take the natural log of this, put that in our calculator, and when I take the natural log of this, I get this. I'm now going to divide both sides by 0.12. And I get then, as these cancel out, t equals 7.63, and it goes on. And they ask us to round to the nearest year, which will be 8 years, and that's our answer. Now, this would be the work needed to support how you got this answer. Notice it involves lots of things we've done in the past, figuring out what K was, and then using our natural log formula from section 5, I believe, of module 6. Okay, so if you get any like this, this would be a model to show how to get the answer. And there's others that are similar to this.